Today I want us to go through these types of integrals. So we have three types of forms, which the first form is when we have the integral of sine x cos x. So this is how we compute such an integral. So if we're working with sine x cos x, this will always yield 1 over 2 sine of m plus n x. You see, right? And then we add 1 over 2 of sine of m minus n x outside. So this is what is gonna be yielded by the sine x cos x. So we're gonna be using these properties. Yeah, so we'll be using these properties of the integrals of this format. Now, so I say that when we are working with sine mx cos nx, this is the type of integral that we'll be focusing on. So I hope we see right. Now, also the one which we work with cos, this is going to give us something that is the same as this, but then we're only going to change sign. So the best way to know these properties is if you know that the moment you're dealing with sine cos, you're only going to write the format of sine. Then if you're dealing with cos, you write the format of cos. So this will be 1 over 2 cos of m plus nx. You see, then after I add 1 over 2 cos of m minus n x. So the difference between the two is we change this only. You see, right? That is the difference between the two. And then the moment when we're working with sine, so it's like when I take this, I start with it. You see, right? I start with it and then I subtract this. You see, right? So the moment I'm working with cos, it's when I say 1 over 2 cos of m minus n x, I subtract 1 over 2 cos of m plus n x. So I think now we can just apply this in some questions. So let's say now we're given the first question. The first question that we're given says that we have the integral of sine 4x cos of 5x. Now if we see we're dealing with sine cos, so we know that we'll have this identity. You see, right? So it means that the identity that we're going to have will be 1 over 2 sine of our m is equals to 4, sine of 4 plus our n is equals to 5, plus 5x plus 1 over 2. So this will be the integral of that. Then this will be sine of this will be what is this? 4 is m minus 5x. So the reason why I'm not putting these integrals here is because you remember when I wrote here, I said that these properties are going to be defining the integral. You see, right? But whenever we apply these properties, even though on the properties they didn't write these integrals. So what I'm gonna do now is this. I want you to write it. So let me do this. So the property in it, right? It says that this will be equal to this. You see, right? So what we need to do now is that know that every time a given sine, you see, every time a given sine cos, you are going to translate this in the form of sine. You see, right? So this will be 1 over 2 sine of the angle here plus the angle here. You see, right? So if the angle here is A, the angle here is B, you're going to have A plus B, you have X. You have plus 1 over 2 sine of the first angle minus the second angle, X. Then the other ones, right, they're always going to be in the form of cos. As long as it's not sine cos, they're always going to be in the format of cos. Then the one which has cos cos, let's say cos of A, cos of B. This will always be the same as this, but then we're going to have 1 over 2 cos of A plus bx plus 1 over 2 cos of A minus bx. Then the moment it becomes sine, you say, right, let's say sine A, sine B. Here we're going to say 1 over 2 cos of A minus B x minus 1 over 2 cos of A plus B x. You see, as long as it's sine. You see, right? The sine is the one which is having a negative outside here. You see, right? So this is what we're going to be doing here. So since here I'm applying an integral, it means that it would be best for me to come and put an integral here so I can remember that this is the case. Or because of space that side, let me just erase these integrals here. Because of space, I'll just erase this and also erase this one. I don't think it will fit that side. Yeah, so I think to best fit our solution, every time when we're creating a problem, we're gonna write that we know that the integral of sine mx cos nx dx, or instead of saying the integral, let me say this, we know that this, and then I'll erase this, then we'll write it down there. Since we're supposed to evaluate it, we know that this will be equal to, if we have sine cos, will be equal to 1 over 2 sine of m plus n x, given that m is equal to 4 and n is equal to 5. That's right. Then this will be plus 1 over 2 m minus n x. So this is going to imply that this integral of sine 4x cos 5x dx will be equal to the integral of 1 over 2 sine of 4 plus 5 x plus 1 over 2 sine of 5 minus 4 minus 5 x dx. You see, right? Then I put brackets there because I have plus in between. So this will be equal to, now I know that I can simplify inside. We agree, right? And take the 1 over 2 out because that one is a constant. So I take the 1 over 2 out, I simplify the inside. This will be sine of 4 plus that is 9. Let me call it 9x like this. It's 9x plus, then sine of, that one is sine minus x dx. We see, right? Then we have a property that says that sine of minus x is equal to minus sine x, and also cos of minus x is equal to cos of x. You see, right? So we have that property. Now applying that property, we're going to have 1 over 2 And then we have there, so I can open here. Then I contribute, let me just, not distribute, man. Let me just do this first before I distribute. Yeah, I'm going to have sine of 9x minus sine x dx. And this will be equal to, I can distribute this. You see right now, the integral sine. I can distribute the integral sine, or I integrate it as it is, but I prefer distributing the integral sine. Integral of sine x dx. This will be equal to 1 over 2. Remember, when we derive positive cos, we get positives. When we derive negative cos, we get positive sign. So it means that when we integrate positive sign, we're going to get negative cos. You see right now? Then I divide by the derivative of the inside. This is how you integrate a function, a trig function. You see right, which is sine or cos. Then minus, this is still positive sine. So it means that when I integrate, I'll get positive cos x divided by the derivative of the inside, which is x in this case. And then I add my c outside. Avoid these things of c1, c2. I saw some they are still using those things when they send me their solutions, and I say that you should avoid them. So when I multiply these two inside, I'm going to get minus 1 over 18 cos of 9x, because the derivative of 9x is 9, right? Plus 1 over 2 cos of x plus c. Any question? So we know that this is the integral of this function. If you have any question, you can ask. If not, we can proceed. So now we come to the second function. The second function, we have the integral of cos of 3x cos of 4x dx. And here we remember that if we have cos of mx cos of nx, this will be equal to the same thing as that. You see, this is cos, right? The same thing as that, but we're using cos. Yeah, if you practice this, that's the best way you can get them in your head. Just practice them and you write them. Where m is equal to, here m is equal to 3 and n is equal to 4. In this case, it doesn't matter what you make m to be or n to be, because at the end of the day, they'll give you the same solution. Because even cos of negative x would be cos of x. So now we have this. And we know that this will imply that the integral of cos over 3x cos of 4x dx will be equal to the integral. Now I substitute those, 1 over 2 cos of 3 plus 4x plus 1 over 2 cos of 3 minus 4x. Then I close this dx. Now this will be, from here we are going to have that this will imply that the integral, not will imply, man, let me leave this out. I'm just going to continue from here. This will be 1 over 2, I take out the constant, have the integral of cos of 7x plus cos of minus x dx. And we know, I've said it, that sine of minus x is also minus sine x, and also I've said it that cos of minus x is equal to minus cos x, positive cos x. You see, right? And then this will be 1 over 2 integral of, or let me just that's fine, I'll distribute after, cos of 7x, start by applying this, cos of x dx. You see, now I can distribute 1 over 2, and I have the integral of cos of 7x dx plus integral of cos x dx. And this will be equals to 1 over 2. You know, when you integrate, when you derive sine, you get positive cos, right? So it means that when you integrate cos, you'll get positive sine. Divide by the derivative of the inside. Which is this. And then this will be plus the integral of this, I'll multiply by that 1 over 2, and then the integral of cos x will be sine x, divided by the derivative of the inside. I add my c. Then this will be equal to 1 over 14 sine of 7x plus 1 over 2 sine of x plus c. You see, right? Any question here? If you have a question, we can look at it. Then if not, we proceed. Now, let's see on the exercises if we can find the one which has to do with sine. Yeah, on the exercises, we can solve this. On the exercises, we have, let me say from the exercise, this is number 7, right? So let me see, maybe let me start with the we have let's start with number 5. We have the integral of cos of 5x sine of 2x dx. You see, right? So now from the exercise we have this, which is number 5. Say we have cos of 5x sine of 2x. Now what we know here is that cos of mx sine of nx will be equal to 1 over 2, as long as it's sine cos, right? So what I can do here, I can say this will be equal to sine of nx cos of mx. I just have to interchange that. You see, right? Just have to swap those, because the property that I know is based on this that we know. You see, right? So this will be equal to 1 over 2 sine of n plus m. This time n comes first. You see, right now, x, then plus 1 over 2 sine of n minus m x. So now we know that from this property we are going to say that this will imply that the integral of cos of 5x sine 2x dx will be equal to the integral of 1 over 2 sine of, in this case n is 2, sine of 2 plus 5 x plus 1 over 2 sine of 2 minus 5 x dx. You see, right? And then this will be equal, so I take out the 1 over 2 as a constant. So it will be sine of 7x plus sine of minus 3x dx. This will be equals to 1 over 2 integral of sine of 7x minus sine of 3x dx. Because we know for sure that sine of minus x is equals to minus sine x, and we know that cos of minus x is equals to cos of x. We agree, right? And then now we can distribute this. So let me just distribute this with the integral sine of 7x dx. That's 1 over 2 integral of sine of 3x dx. And this will be equals to 1 over 2. You know the integral of sine x will become minus cos 7x over the derivative of the inside. Integral of this minus cos of 3x divided by the derivative of the inside plus c, because all the integral signs are gone, so I'll just add c there. So it'll be minus 1 over 14 cos of 7x minus 1 over 6 positive cos of 3x plus c, because negative times negative is positive, right? So it's our positive there. Then this is the solution that we're going to get. Any question? If you have a question, you can ask, and if not, we can see. You guys don't have questions, right? Alright, if you don't have questions, it means that I can proceed. So now we can go to I think it's number 7. We can go to number 7, and then we see. So let me say this 7. Number 7, yeah, it's this one. 7, it's like this. So it is the integral of cos of 2x cos of 3x dx. Yeah. So from this one, right, we know that we can easily look for look for the integral, right? Because we know what function we're dealing with, and we know how to interchange the function. We agree, right? So, and we know that the function of this one is as follows. So the function will be, we know that cos of mx, so this one is just cos, so I'm gonna write cos of mx cos of nx, which will be equal to, it's the same as the previous one, right? And then the difference is that this one we're gonna change the sign and write the cos. You see right now. So we're gonna change the sign and write the cos. So this will be 1 over 2 cos of m plus n cos, then plus cos of m minus n x. You see, right? Then this will imply the integral of cos over 2x cos of 3x dx will be equal to the integral of 1 over 2 cos of 2 plus 3x plus 1 over 2 cos of 2 minus 3x dx. like that. Now we can take out a constant. We agree which one is a constant here, which is 1 over 2. You see, we have been taking out 1 over 2 for a while, right? Now we can also take it out from here. We say that this will be 1 over 2 integral of cos of 5x plus cos of minus x dx. This will be 1 over 2 integral of cos of 5x dx minus the positive, because cos of negative, that is positive, 1 over 2 integral of cos of x dx. Or if you want to start by changing this to positive there, and then this will be equals to 1 over 2. This will be the integral of positive cos. We know it's positive sine. You see right now, divided by the derivative of the inside, plus 1 over 2 positive sine divided by the derivative of x. I add c now. This will be 1 over 10 sine of 5x plus 1 over 2 sine of x plus c. Any question? If you have a question, you ask. If not, we proceed. Now, we have number 8, which is based on the sine. Now, on the exercise, we're given that number 8 is as follows: is the integral of sine. This one is 7. So 7 over 2 x sine of 1 over 2 x dx. And we know that sine, the sine of mx cos of sine, the one of sine only, sine of nx will be equals to, we start with subtracting here. You see, right, we're using cos, we start by subtracting. You see right now. Then minus 1 over 2 cos of, then we add here on this property. You see, right? Then this will imply that the integral of sine of 7 over 2x sine of 1 over 2x dx is going to be equals to, I just put the integral there and this, cos of 7 over 2 minus 1 over 2 x minus 1 over 2 cos of 7 over 2 plus 1 over 2 x. This will be equals to, take out the 1 over 2 as a constant, is the integral of cos of, this is 6 over 2 and 6 over 2 is 3 x minus 1 over 2 cos of, this is 8 over 2 and 8 over 2 is 4 dx. And then this will be equals to 1 over 2 integral of cos of 3x dx minus, oh, I didn't take out this 1 over 2 here. Minus 1 over 2 integral of cos of 4x dx. And this will be equals to 1 over 2. If I integrate positive cos, we know we get positive sine. Divided by the derivative of the inside. The same here, get positive sine divided by the derivative of the inside. and then we add our c. You see, right? And then this will be the divided by, we get 3 divided 2 times 3 is 6 sine of 3x minus, this is 4 times 2 is 8 sine of 4x plus c. We see, right? So it will be simpler for us to work around this. So I hope we agree. If there's no question, it means that we can proceed. So now, since we have seen this, we can say that I'm sure that if a question like this comes up, you are ready. I believe we agree, right? So yesterday we even touched part of the definite integrals. So you know how to integrate when they said 1 year, 7 year. I'm sure you know that if you came to class yesterday. And then now from this we can say that now let's go back to look at this. I think I want to show. This will just be a revision, right, from what we have covered before. So now on this revision, we're going to look at the integral of. We're gonna look at the integral of sec x dx, and also we look at the integral of cosec x dx. We agree, right now? And here, given that we know that from here, we know that the derivative of sec x is equal to tan x sec x. You see, right? And also, we know that the derivative of cosec x is equal to minus cot x cosec x. We see, right now? So you understand now. Any question? Any question, guys? So if you don't have questions, it's fine, then we can proceed. So now when we have this, what you're going to do, right, as long as you know the derivative, only when you're integrating this two. When agree, we know the derivative of sec, right, sec x. What you're going to do, you're going to consider this tan x, you add the plus in between. Make sure you always start with the opposite function. Like it's sec, we put x at sec at the end. Then here we consider minus cot x, we put plus in between sec x. Make sure that this is always at the end, the one you're dealing with, or else you'll have a wrong solution when it comes to this one, because the cot should be negative when you're having this. You just consider that you put a plus in between these two functions. And then we come to integrating sec x dx. When we integrate this, we're going to say sec x times tan x plus sec x over tan x plus sec x dx. You see, right? Then this will be equal to the integral of sec x tan x plus sec squared x all over tan x plus sec x dx. And then we use this substitution to say we're going to let u be equal to the denominator. We always let this be equal to the denominator. plus sec x. Every time you derive this denominator, guys, as long as you're integrating sec x or cot x, you're always going to get the numerator. So we know now that the derivative of this will be I just write that numerator. Because I know that derivative of tan x is sec squared x, and derivative of sec x is sec x tan x. You see right now, I write dx here. Then I make dx with the formula. I'll have du all over sec x tan x plus sec squared x, which is equal to dx. Then from here, I just go back to substitute. We know that this will be equal to the integral of sec x tan x plus sec squared x all over u times du all over sec x tan x plus sec squared x. Then this will cancel out. I don't have to show, guys, you don't have to show that they're cancelling out. Just exclude them on the next step, because you guys, when you show, you erase things that the lecturer can't see. You see right now? Don't cancel out, just omit them on the next step. And we know that the integral of 1 over u will be ln u with absolute values plus sin. Then we substitute back our ln, our u, man. Our u was tan x plus sec x plus c. You see, right? So that is how you integrate sec x. So now we come to integrating cosec x dx. We know that this will be equal to what we got there. We will first write this cosec x times what we got there is that we got this minus cot x plus cosec x. So I can just start with the cot x here, so I can just rearrange them minus, so I don't have to put brackets. I get it. Avoid these things of saying these terms minus. This is error, guys. This doesn't exist. If there's a minus between that function, just put brackets instead of a dot. You see, ne? Such a case doesn't exist. Avoid such things. Dx. Then this will be equal to the integral of cosec squared x minus cot x cosec x all over cosec x minus cot x dx. And now we're gonna use the absolute substitution. We let u be equal to cosec x minus cot x. So when we derive this, we're just going to get that denominator, that numerator. We know that the derivative of cosec x is minus cot x cosec x, and the derivative of cot x is minus cosec x. So that's why it will become positive, this one, when we derive negative cot x. Then minus, that's why we have to copy the numerator. Just make sure you copy the numerator so you don't have to make mistakes. You see right now, times dx, put brackets there. And then I make du subject the formula. So be cosec squared x minus cot x cosec x, which is also dx. We see, right? And then I go back to substitute. This will be, I'm going to have equals to this will be equals to the integral of cosec x cos, do this integral of cosec squared x minus cot x cosec x all over, that is u, and then this is du over cosec squared x minus cot x cosec x. Then those will cancel out, right? Then we'll be left with the integral of 1 over u du. And this is ln of u plus c. And this will be equals to ln of, there we had the cosec x minus cot of x as our u. You see, right? And then that will be the integral of cosec x. Any question? If you have a question, you can ask, then we'll see what we do. And then, now we know how to integrate such a case, right? So we can come to integrating this. If there's no question, we can come to this integration. Now, let's say I'm given such a question like this. I'm given, let me say, consider. Now, we're going to talk about the integral of something like maybe tan that has more than one exponent, or sec squared, how to integrate such case. You see right now. We're gonna be looking at these ones. I get here there were only one case, we only had this, but how to integrate something like this, and also like this. You see right now. So now we can consider that sec squared x is equal to tan squared x plus 1, and we consider that cosec squared x is equal to cot squared x plus 1. So we consider these two cases, right? Then we have the first case and the second case, whereas in we're gonna apply both the case. So we know that this one will mean that tan squared x is equal to sec squared x minus 1. And this will mean that cot squared x is equal to cosec squared x minus 1. You see, right? And then we have this. Now, since we know what this is, now we know that we're going to have to apply any of these within the integral. We're going to either substitute or something like that. So now we are going to have this first question, which is the integral of tan to the 5 x dx. Now you remember every time we have an exponent that is like this, that is odd, right? And every time we have an exponent that is odd, we must try to change it to this. Even if it's even, we must try to change it to either of these. That's right. Every time we have such a case, we must try to change it to either of these. As long as it's tan, it can either be the integral of tan, the integral of cosec, the integral of sec, as long as it's to the exponent something. You see right now. And then we're always gonna do this. Now, for this one, if we were looking for tan squared x here, we can drop it like this, 3x dx. You see, right? And we know that this one, we know that tan squared x is what? We know that tan squared x is sec squared x minus 1. So this is what we're looking for. You see, right? Then from here, we can easily try to expand. You see, right? So when we try to expand this, or to simplify this, we get a tan to the 3x sec squared x minus tan to the 3x. So the idea here was just to expand this. You see right now. So what happens here is that we're going to have this is equals to, we now distribute the integral between the two. This will be the integral of tan to the 3. It's like I'm trying to simplify this. Squared x dx minus the integral of tan to the 3x dx. Now you also know how to integrate tan to the 3x. You see, right? So I'm going to show you how to do that now. So let me start here. Now let's look at the first integral here. We have this integral, which is tan to the 3x, tan to the 3x, and also sec to the 3x squared. Now, if we want to integrate this one, the exponent is odd. I'm going to drop one of this, tan. You see right now? So the other one can be squared. If I want to do that, do you agree with me there? If I want to do that, I'm going to drop one tan. Do you agree? So on the first one, I can just let tan be u, so that when I derive tan, I get sec squared x, it cancels out. You see right now? So here, let me work on dropping one. Yeah, I'm going to have tan, and this will be tan to the third x sec squared x dx. This will be minus the integral of tan, and this will be tan x tan squared x dx. Do you agree with me on this one? It means that we can do this, right? We can drop this, then we know how we would integrate something like this. Do we agree that we can drop it if the exponent is odd? So I think if you keep quiet means that you agree. So what you're going to have, first I don't want to solve this now. Let's just wait for us to simplify the other one on the other side, because this one is simple to solve. We know that we can easily let tan. And I'm just gonna simplify the other one, that side. And the same steps, guys. Remember here what I did first. I dropped the tan, I changed it to sec squared x minus 1. Then I simplified through. Here I'm also gonna do the same thing if I was given tan to the 3. You see, right? I dropped the tan, I simplified that, I changed it to sec squared x minus 1 dx. Then I multiply through. That's what I'm going to do. It's like the same steps. You see right now. I'm going to apply the same steps. And as the integral of sec, no, let me start with the tan x sec squared x minus times negative is positive, so I can just simplify this like this. Tan x. We know how to integrate tan x, guys. It's simple. The integral of tan x, you can do it. These two now are a bit similar. If you just let tan x be u, you can cancel that out. You see right now. So let's deal with the last integral first, and then we can come back to this too. Now the last integral, if we want to integrate it, the integral of tan x dx will be equal to the integral of sine x cos x dx. You see right now? So we know now that when I want to integrate this, I'm going to let cos be u. So I let the cos of x become u. When I derive this, I'm going to have minus sine x dx. Then I make this subject the formula. I'll have minus du over sine x, which is equal to dx. I go back to substitute. This is sine x all over our u there, minus, you see there's a negative there, so I just put brackets, sine x. The sine x will cancel out, right? All I have the integral of 1 over u, I put the negative there, and this will be ln of u. You see right now? So this will be ln of u. So we know that ln of u is what? Ln of u will be ln of the cos of x plus c. Do you agree here? So this will be something like this. So we know that the derivative of tan will be ln of cos. Only question. So the derivative of tan can be in two ways, right? There are two ways. I prefer this one. The other one says that the derivative of tan is ln of sec. You see, right? The other one says this. So, which is I don't prefer it, right? Always use this one, which is, yeah, this one will be negative because there's a negative there. Always prefer this one. So the integral of tan can be two things. It can be ln of sec x plus c. Why is it ln of sec x plus c? Let me show you why they did that. Already we have negative here. You see, right? This will be ln of 1. We know that this is 0. Ln of 1 is 0. Ln of cos of x plus c. And then we know, according to the properties of log, that log of a over b will be equals to log of a minus log of b. Or we know this one, that log of 1 over b will be minus log of b. You see, right? Because log of 1 is 0. So this is the same thing. So this will be ln of 1 over cos of x, which this is ln of sec x. So I prefer that we only stop here at cos. We stop there, right? I prefer that we stop there. So I prefer that we stop there. So we know that the integral of this I can't add c because we still have integrals this side. So to work with the other integrals, right, I'm just going to let u be equals to tan x. When I derive this, I get sec squared x dx, which would mean that du over sec squared x is equals to dx. You see, right? Then when I go back to substitute there, I'm going to have u to the 3 sec squared x du over sec squared x minus the integral of u sec squared x du over sec squared x minus ln of cos x. Then this will be equals to the integral of u to the 3 du minus the integral of u du minus ln of cos x. And then this will be u 3 plus 1 over 3 plus 1 minus u 1 plus 1 over 1 plus 1 minus ln over cos of x. Now I add the c. Then we know that our u is the tan. So this will be tan for x over 4 minus tan squared x over 2 minus ln cos of x plus c. Do we agree? We agree, right now? that this is how we're going to integrate this course. So this is the case how we're gonna integrate this. Any question? And guys, after here you must practice. We don't have time. I think today will be. I won't go back to this type of integrations again. So I want you to try this now. I want you to try. I'll write this for you to try. Let me see which one can you try. I want you to try this. Yeah, and I want the solutions, right? Try. I want you to try the integral of cosec x dx. Also, you must try the integral of sec 3x dx. And then we'll do corrections for these ones. I just want you to try them. And then we have this one, which is a mix. It's the integral of tan x sec 5x. So I'm just combining what I told you, right? So that I want to see if you really can work out with something that you see for the first time in the exam. So you should be able to apply the knowledge that you're given, right, to solve any of these. So yeah, I think let me give you the integral of tan squared x sec x dx. And then one last one will be this one. But no, I'm giving you 7. Then this will be sec 7 5x dx. And this will be sec 6x dx. Yeah, once you can solve this, trust me, you'll be ready, right? Once you can solve this, you'll be ready. Now, let's come to trig substitution, right? Now we come to trig substitution. When we are at trig substitution, we're gonna be looking at 3 functions, right? Which the first function we are talking about, this one, a squared, which is a squared minus x squared, which this will have to solve it like this. So we're going to set. So we said every time we see this case, we said x will be equal to a sine u. And then the second case is when we see this one where it's positive. So whenever it's negative there, you set sine. Then when it's positive, we set x being equal to x tan u. When the x is negative, we set sine. When they're all positive, we set tan. And when the a is negative, we set sec. You see right now? Then now we have this. We set x being equal to, I wanted to say a, man. A sec u. So we're gonna be looking at this. You see right now? So we'll be looking at this. Then we apply some cases where we have to see if we're gonna get to the solution or not. And B, this happens for all a greater than 0. So a should always be greater than 0. Now, we come to the first question. The first question that we have is this one. We have that we are given the integral. They say find the integral of the root of 4 plus x squared dx. You see right now? Then we realize that they are all positive. So we're going to set tan. You see right? So when they're all positive, we set x being equals to tan. Or before we set tan, I think we can look at our conditions. What is it that we have? You see right now? So here we know that a is equals to 2, because 4 there is in the form of 2 exponent 2. For this case, we said x being equals to, so our a is 2, so this will be 2 tan u. Then I derive this. You see right? When I derive this both sides, I'm going to get, when I derive x, I get 1 times dx, which is equals to, when I derive tan u, I get 2 sec squared u times du. I'm sure we agree here. Then we go back to the equation. This says that the equation says that the integral of 4 plus x squared dx will be equals to, we have 4 plus our x is 2 tan u squared, and our du, our dx is equals to 2 sec squared u du. You see right? Then this will be equals to, oh, I forgot the integral here. This will be equals to the integral. Then I simplify the inside here. This is 4 plus 4 tan squared u. Then this is 2 sec squared u du. And this will be equals to the integral. I factor out 4 inside. With 1 plus tan squared u times 2 sec squared u du. And we know that sec squared u will be equals to tan squared u plus 1. You see right now? So we can easily substitute that. We can easily substitute that. So this will be the integral of 4 sec squared u times 2 sec squared u du. I hope we agree here right now. Then here we're going to get the integral. If I apply in a root here, I'm going to get 2 sec squared u times 2. No, not 2 sec squared u, it's 2 sec u, because the squared will go, times 2 sec squared u du. And this will give us 4, so we take out 4 outside as a constant. This will be sec to the 3u du. And we know how to integrate sec. I gave you sec something here, right? I think I gave you sec 3x. It means that if we had integrated this, we would know how to integrate that one. So let's integrate it there. Now, the question is, how do we integrate this? So remember, this is squared, right? And I said that when you come across the integral of sec, you must change it to this. So what you're going to do is drop 1 sec there. So we're going to drop 1 sec. Or instead of dropping 1 sec, there are many ways we can try to integrate that. We agree, ne? But this is the best way which I think that you should apply. All of us should take this way. Sec squared u sec u du. And we know that sec squared u is what? Is a tan squared u plus 1 sec u du. Then I can easily do this, the integral of tan squared u sec u plus sec u du. You see, I've expanded that. Then this will be the integral of tan squared u sec u du plus this will be the integral of sec u du. You see, right? Now we can easily integrate sec u. We know how to integrate sec u. I've shown you how you integrate sec u. So let's go back. Sec u, I showed you that you get sec u plus tan u, the ln of sec u plus tan u, which is this. You see, right? So you see that all these are going to contribute on trig substitution. If you know how to integrate this, you can get there. So we know that the integral of sec u is this. So we can just go write that there on sec u. The integral of that is that. Then what is the integral of tan squared u sec u? I think I've also given to you here as an exercise. Tan squared x. So you see here, in other words, if you solve this, you would have solved this also. You see, right? So initially we solved this, we are also solving this in the same case. So I don't want to hear you saying that you don't know the answer to this too. You see, right? Because we are solving them simultaneously. So how do we solve this one? Tan u sec u. You see, right? So the easiest way to do that, you can even try to change the tan to sec squared u minus 1. You see, right? You can do that if you want. The integral of this is ln sec u plus tan u. And then this will be this. We agree, right? And then now I come to this one where I want to integrate sec this u. So for me to integrate this, I'm going to have let's say I can multiply through, let me see here, it's gonna, yeah, this I can multiply through. I'm going to have sec 3 u minus sec u du plus ln. Really, let me just multiply through this 4 because I think we'll need it. So you see, right? And this will be 4 sec u plus tan u. So now here I'm going to separate this. Let me start here. At first here we had that what we're don't forget we're integrating this right now. Sec this one, we're integrating this one sec 3u. So we're integrating sec 3u du, which this is equal to this will be 4 integral of sec 3u du minus integral, let me see, it's 4, I think this is 4, then this will be tan that sec u du plus 4 ln of, yeah, I might do, yeah, here it's supposed to be, I think even here it's supposed to be 4, yeah. So we had the tan u sec u, that we integrated the sec u, then we got back to tan u sec u, then we went back, we have the tan u sec u plus sec u, and then we know that the integral of sec u is ln sec u plus tan u, and then we interchanged tan u to sec u minus 1. And then from here we I think you multiplied it through, and then we get the sec to the 3 is sec u du, while we multiply the 4 inside, and then we come here to say this is equals to the 4 sec u sec to the 3u du minus this, and then plus the sec. So let me see if there's no easier way to do this, because this one it's gonna take too long, right? It's gonna take us too long. So let me see if we can try this. Yeah, I think, but this is the easiest. It's the easiest, because the other one is gonna take us to use by parts, and I don't want to use by parts here. Let me see. It's gonna be too long. Like this. Yeah, this is the easiest way. So let me just do this. I think for you to best understand this, let me erase this and put it like this. So I want to put it in a way that it will be understood. Yeah, so let me close this. So now we know that from here, so I just want to specify this, that from here we were trying to integrate 4 sec to the 3u du, so you don't get lost. So we dropped 1 sec, we changed that to tan, which is correct. We have the tan u sec u plus sec. When we separated this, we know that the integral of sec u is ln of that. And then here we changed the tan to sec u3, this, and then we change this to sec u minus 1. Then I distributed the 4, which in this case I got 4. I'm gonna write it here. And here was 4 integral of sec 3u du, which is equal to 4 integral of sec 3u, and then this is du minus 4 integral of sec u du. Then I want to see if this is going to give us, and the ln. Then this one will give us the 4, then that will cancel out. So let me see. Yeah, this is just, I think this one just proves that it's correct. So let me try another method here, because this one is going to give us 0 equals to 0. Yeah, just from here, I think I'm going to try another approach, which is a bit similar to this. Sec u minus, this is sec u du. So I'll just put this here, plus ln of sec u plus tan u. So it means that this will be equal to 4. So this will be 4 integral of, if I change that, I go back, it's gonna take me back, right? And then I'm gonna have the tan, and this will be integral of sec, still it's gonna take me back. Let me see if there's no easier way to do this, or else we'll be forced to use by parts. Or let me, maybe the problem is this 4. Let me integrate it without the 4, then I see if it's gonna take me to the correct solution. If I take this alone, sec 3u, I think we can just integrate this, then we plug back, and then this will be sec squared x sec x du. Yeah, I think it's best if we just use this one. So now I know that if I take, let me see, if I take this one of it, and then I integrate. This will be, instead of changing the squared x plus 1 sec x du, not sec x man, sec u, u, and this will be equals to the integral of tan squared u sec u plus sec u du. And then this will be equals to, then here I'm going to have the integral of squared u sec u du plus the integral of sec u du, which is fine. Then I'm going to have, this will be equals to the integral of, this one will change to sec 2 u minus 1 sec u du, plus this one will give us the ln of, and maybe let me even before I think about the ln, sec u du, and this will be equals to, then here I'll have the integral of sec squared u du minus the integral of sec u du plus the integral of sec u du. Then that will go, right? Then I'll be left to integrate the integral of sec squared u du. And then in this case, I'm going to have, if I integrate sec squared du, I'm going to have let's see, integral of sec x du. Yeah, I think also this one will be too long, right? But that's fine. I think we can use by parts. I don't want to use by parts, but with by parts it will be fast. So let's just use by parts. We have no choice. So with by parts, right, this is just an alternative way to do it. If you're doing the integral of sec to the third u, you just drop 1 like the other one. All of them will drop in 1. You see, right? So, but instead of changing this to tan, you have to let one be u, let the other be dv. Remember I said yesterday that those who attended, you remember I said that when you're doing by parts, you consider the one which is the most easiest one. So between sec squared u and sec u, the most easiest one is sec u, right? So I'm going to let u be equals to sec u. So the most one which is simple to derive, it's sec u. Then I let dv to be equals to this sec squared u. So this one, instead of u, let me use w because I already this thing is in the form of u, right? Then this will be dw is equals to the sec is sec u tan u du. Then this one, if I integrate what's this there? If I integrate the sec squared u, you know that when you integrate sec squared u, you're gonna get tan x. You see. So the reason why I stopped on that one, I realized that the integral of sec squared was gonna be tan x, and tan x can be equal to this. Is that right? So now I go back to substitute. When I substitute back, I'm going to have this. So this will be equal to the integral of sec to the 3x dx, sec to the 3u du, which is equal to, well, let me write it in a clear way. This is the integral of sec to the 3u du, which is equal to, this is gonna be wv minus the integral of v dw. So w is sec, here it's u, it's with respect to u, right? Sec u then the w sec u, and then the v is a tan u, minus the integral. Our v is tan u, then this will be the w is sec u tan u du. You see, right? Then this will be equals to sec u tan u minus the integral of tan squared u sec u du. So here will be sec u tan u minus the integral. We know that when we have tan squared u, we change it to what? To sec squared u minus 1 sec u du. This is equals to sec u tan u minus sec 3u plus the integral of sec u du. And then this I can take it to the other side because this is the same as this one, right? So I'm gonna have 2 integral of sec to the third u du, and this is sec u tan u minus or plus the integral of this. We know what is it, right? We know that that is ln of sec u plus tan u. Then I'll add c. Then when I divide by that 2, I'll have 1 over 2 sec u tan u plus 1 over 2 ln sec u plus tan u plus c. Then this will be the integral of sec to the third u. But this is having 4. You see, right now? So this will imply that 4 sec third u du will be equals to 1 over 2 times 4 is what? Is a 2, right? Sec u tan u plus 2 ln of sec u plus tan u plus c. You see, right? So now we know how to integrate sec to the third u. So it means that now we can continue to apply this here because we know now what function we got. We agree, right now? We know what function we got. So since we have this as that function, right, so we can come and draw this. We remember that we had that we let x be equals to 2 tan u. We agree, right now? We let x be equals to 2 tan u that time. And the original equation said what? The original question said that we must integrate the root of 4 plus x squared du. Do you agree here? That is what we were told to integrate. Do you agree that that is what we were told to integrate? So to be simple for us to simplify this. So now if we go back, let me do this. Where was the initial question? We say that a is 2 and we say that x is a 2 tan u. We agree, right? And now want to see what is it that we can get from this. So we are going to look for tan. What is the meaning of tan? You remember we had something like I think it was so kato. You remember, right now? From high school we had something like this. Do you agree that we had something like this? We had something like this from high school. We had something like sokato. So if I make tan u here substitute the formula. If I make tan u substitute the formula, I'm going to have tan u is equals to x over 2. We agree, right? Tan u will be equals to x over 2. And then we know that this one is the hypotenuse, and then this one is the adjacent, this one is the opposite from this angle. You see, right? So yeah, now when we are here, we're saying that tan u is equal to O over A. Do you agree here? We're saying that tan u is equal to O over A. We say, right, we are saying that tan u is equal to O over A. So when we are saying that tan u is equal to O over A, we're gonna do this. We're gonna have here, let me start by plugging the simplest one. Our opposite angle is x, our adjacent is 2. So we're gonna have this. Do you agree with me there? So we're going to have this x2 from this opposite adjacent. And then nextly, what we're going to have, usually you can still do this, or you just take the simplest thing which you see. You see, right? Or you can just take the simplest thing which you see. Which the simplest thing in this case, instead of having these arctan, you can just take the original question, which the original question say that we must have 4, it's 4, we must integrate 4 plus x squared. Then you put it on the empty side. You see, right? And then we were able to sketch this. For always, you should be able to sketch this. Well, after sketching this, you lose it. Now, let's copy back this and see how we're gonna use it. So if I come and paste it here, I know that this will be equal to 2. Now I must look for the other one, right? So the other one, right, which is the opposite of this, we are just going to say this. We are just going to interchange this. We say that. And we know that the opposite of sine, or the inverse of sine, is what is the inverse of sine? The inverse of sine, what is 1 over sine? It's a cosec. You say right now. The inverse of cos is a sec. And the inverse of tan is a cot. You say right now. So usually some they used to call it koshako. You say right now. So now we're gonna look for sec u. Sec u is here. Hypotenuse over adjacent. It's this over 2. You see right now. Hypotenuse over adjacent, which is 4 plus x over 2. We look for tan u. Tan u, we know that it's what? It's x over 2. That one is obvious. We have it already. X over 2 plus 2 ln of sec u. Already I know that it's the root of 4 plus x over 2 plus this is x over 2 plus c. We say right. So I can easily simplify this. This will be equal to, the 2 will cancel the 2, I'll be left with 1 over 2 x root of 4 plus x. And then this will be plus 2 ln of, if I multiply them both, this times that, I'm going to have 2 root of 4 plus x plus 2x over 2, this is 2 times 2, or maybe I can just add this. This is the simplest. Instead of doing this, I get the base is the same. I just add this 4 plus x over 2 to simplify things. You see, right? And then this will be a simpler approach. Then what you can just do, You can just simplify it further if you want. You can just simplify it further. This is 2 ln of 4 plus x minus 2 ln of 2 plus c. We see, right? Then if you want, you can take this 2, put it on the exponent. Now, is there any question? Any question? Any question? So here you would realize that at some point, maybe let's say in some case, you find that the answer is this. It's because this was considered to be a constant also. So this, just that I don't want to discuss about that one, but this one can be absorbed to be a constant. You see right now? So that kind of a thing can be absorbed to be a constant. So it means that we can also be allowed to write one, as long as there's no x in there. It can be absorbed. So don't be shocked when you see solutions like this. That can be absorbed. You see, right? That is absorbed to be a constant. So if there's no question, I'm gonna stop the recording.